Okay, in this next series of videos, we're going to be looking at the area of special quadrilaterals. So we've previously looked at the area of some, different shapes, including the rectangle, square, and the triangle. But now we're going to be looking at different ones that we can use or look at to help calculate. And we're going to need to know some formulas. So the three or four shapes, that we're going to be looking at. The first one will be the parallelogram. We'll then look at the rhombus or the kite, and then finally the trapezium. So as we go through these video series, making sure that you're taking your notes, writing down the formula, and we'll do a couple of practice tasks as we go through. So the first one we're going to be looking at here is the parallelogram. And I've got a drawing here, an image, just so you get an example of what that looks like. It looks like a rectangle. Rectangles are parallelograms and so are squares. But you'll see here that it's sort of like an extrude, it's on a sort of a slant, like a type of rectangle. And what you need to make sure you notice is that we've got these sort of symbols here which represent the same. Okay, so these two lines here with those two arrows, they represent that these two are parallel and they're the same length. These one with just the simple or the one angle, these are also parallel and they're also the same length. So the formula for this is area equals base times height. Now I'm going to give you an example. I want to show you why we do this and how this will all make sense, because basically this is effectively a rectangle. Now, if I did if I cut this down here, okay, if I cut that shape or the end of that parallelogram there, and I move that to this side, that will effectively fit in to that space there. So what we now have is basically a rectangle. So by simply cutting that part off, moving in here, we have a rectangle. So it's very similar to the formula for a rectangle of area equals length times width. Okay, so it's length times width, and you'll just see it's called base times height. So it's the same thing. We just want to use different terminology as we get forward into more different quadrilateral shapes. So it's basically saying length times width or base times height. Now the base times height refers to the base being obviously the long distance at the bottom and the height being the distance in between from the top to the bottom. And we're just going to calculate that there. So I'm going to do an example here. I'll put out some units on here and we're going to show you how we can calculate the area of the parallelogram. Here is our example here. We've got a parallelogram. We've got the base of 8 and the height here is 3 meters. So we simply just write the formula down. So it's area equals base times height. Now, if we substitute these values into our formula here, with base, which we know is 8. Okay, there's our base there. So it's basically saying 8 times the height of 3. And then we can just simply do the calculation of there. So 8 times 3. 8 times 3, as we know, equals 24. And we're also going to be putting in the units of measurement, which is, of course, meters. And because we're calculating the area here, that is also going to be meters squared. So just a recap of the parallelogram. To find the area, it is simply base times height. And as we've seen in the example here, we can basically just make it a rectangle by trimming that off, replacing it there. It is a rectangle. That's why its formula is very similar between these two. But we want to use the terms of base and height times height. So therefore we calculate it. We do area equals base times height. We calculate them together, making sure you add in your units of measurement at the end. The next video we're going to be looking at rhombuses and kites and also trapeziums. Thanks, guys.